All right, so silence, please. So this is an example of a problem where the trajectory of the object is going to be something like this. Could I have your attention, please? It's going to be something like this. It's going to go up and down. It's going to land lower than it started. Okay? So if you recall, one of the things that we could do when it started and stopped at the same elevation, that is like this, right? One of the things we could do is you could say it took half the time to go up, half the time to go down. Do you remember that? So tonight on how far 3 number 1, right, you'll be able to use that. It's like in the air for a certain time, cut the time in half, that's when it's at the top, et cetera, right? We've already done that. This one's going to be different. We can't say that. It's not going to spend half the time going up and half the time going down because it went farther down, right? Yeah? So I kind of gave away the first question, right? Describe to your neighbor what the piece will do. Well, if a piece falls off a rocket that's moving upward, right, the piece is going to continue upward for some period of time, yes? Yeah, and then it's going to go down and hit the ground, right? Yeah? So a picture of this looks like this. Here's the ground, right? It's 27 meters above the ground, so it leaves here. That's 27 meters, right? Right? And then we think it's going to go up from here to some height and then go down and strike the ground, right? Okay? And then if you look at the questions here, if you look at the questions, 2 is a different question. 3 and 4 we can solve, and they're concerning this part of it here, starting here and going there. So I suggest let's do 3 and 4, 2 and 3, 3 and 4. Let's do 3 and 4, 3 and 4. That was the hardest part of the faculty dance for me. It was when we had to go 5, 4, 3. It's like 2. Oh, whoops. Right. Anyway, okay. But let's do 3 and 4 first. Then let's do number 2. It doesn't matter what order, but let's just do it that way. Okay. So 3 and 4 talk about from here to hitting the ground. All right. So what do we know from when the rocket piece falls off to when it hits the ground? What do we know? Who knows what we know? Raise your hand if you know what we know. Braden knows something. The whole time it's going to be accelerating up or down. Yeah, indeed, it's going to accelerate down, right? So when it's on its way up, right? When it's on its way up, it's slowing down. When it's on its way down, it's speeding up, right? But the whole time it's accelerating down. What else do we know? The what? The initial velocity is? Do you say 21? Yeah, there we go, yeah. It's going to be going up with the rocket, right? Positive 21 meters per second. So we assume it's got the same velocity as the rocket had. Yeah? Are we good so far? And now we've got to be very careful. Remember that x means the net change in position. What is the net change in position from here to here? Be very careful. Or as they say on my language tapes, be careful of the word order. It's like, that just means you're not going to get it. You know? What is the net change in position from here to here? 27 is the distance. What is the net change in position? Do we care what direction displacement is? Yes, we do. What is the net? Who said negative? Is it negative? Yeah, negative 27. Indeed, yeah. Now, that's tricky, right? Negative means down, 27 means meters, right? 27 meters, yes? Okay. Does it make sense that it goes down 27? That is the net change in position. Now the next thing that you have to believe, that a lot of kids don't believe, right, is that that it's not distance, because the distance is much more than 27, correct? The distance is like it goes up some amount and goes down some amount, right? And then it's going to go up a long way, right? That's not the distance. X means literally this change in position. Okay. Now that we have three things, right? Let's find both things. It's asking us for what's this and what's that. So who's got a formula that'll find either one? Find a formula. Raise your hand when you find a formula we can use. That's Paul back there. What do you got? Say again? Yeah, this guy here for time. So let's just pull that guy out, right? Okay. So we'll go x is VIT plus 1/2 AT squared. And then we just plug the numbers in. Minus 27 is 21 times t plus 1/2 negative 9.8 t squared. And we just solve that for t, yes? Why do I probably not want to do that? Why do I probably not want to do that? Is that easy to solve for t? Or do we have to do the quadratic equation? Now, the problem is I know that you guys did the quadratic equation in 9th grade, didn't you? 8th grade, something like that, didn't you? Right, so I don't really feel all that sorry for you, but there's a workaround. We don't have to start with that one. So let's just sort of go, yeah, we could do the quadratic equation, right? Which, what is it, minus b plus or minus the square root of b squared minus 4ac over 2a. Is that what it is, or something like that? Yeah, okay. Let's not go there, though. Okay, what's the other thing we could solve for, and what's the formula that would solve it for us? The final velocity, right? Which one would solve it for us? First one won't do it. The very last one, right? So let's do that one, right? Take this guy. Right, so the final velocity is what we want to find, right? The initial is 21 squared plus 2 times negative 9.8 times negative 27, right? Take your calculator now, and by touching your calculator that you already have out, okay, touch that calculator in such a way as to get the answer. Now, be very careful when you get the answer, because remember, you're going to have to square root. You're going to have to get all this stuff on this side, get it, and square root it, won't you? What is true when you square root a number that's been squared? What is negative 2 squared? 4. Square root of 4 is 2. You don't get the number, do you? You get the absolute value of the number, correct? So what you need to do is when you get this answer, you've got to think, gee, could that be negative? Okay, so do that right now. Touch your calculator, solve it for VF, okay? And when you get that answer, decide, should it be negative or should it be positive? In this case, what does negative velocity mean? Moving down, and positive means moving up. Yeah. Okay, I'm thinking you're going to get that. You do that, I'm going to take attendance. Cardenas. You don't need to do it on a whiteboard, just do it in your notes. Yeah. KC. Get a calculator out. Paul. Oh, he's got one. Hudson. Borrow one. Do you guys all have calculators? Go borrow one. Don't sit there like a lump.